All right, geometry. So the last section on similarity has to do with right triangles. And this is kind of a good segue because the next chapter, chapter 8, is about right triangles. So, like I said, a good way to kind of bridge the gap between the two chapters. Okay, so what we're talking about here is this specific idea. Okay, so what this says is the altitude to the hypotenuse of a right triangle. So let's talk about what that means first. So the word altitude just means perpendicular, so a perpendicular segment. All right. So what they're talking about here is they're talking about in this big right triangle, ABC, where angle C is the right angle. This segment CD is called the altitude. It's called the altitude because it is perpendicular to this hypotenuse. It goes from a vertex across the triangle perpendicular. So what this does is it divides the big triangle into two other triangles that are similar to the original triangle and to each other. So what happens is you have one big right triangle broken into two smaller right triangles, and all three triangles are similar. So why are they similar? Well, let's investigate that. First of all, each triangle is a right triangle. And if each triangle is a right triangle, then each triangle has a right angle. So that is going to be one congruent angle pair for each triangle, right? So we have angle C for the big triangle and the two angle Ds for the small triangles. And again, if you want to see here, here's the small triangles. And now what about the second pair of congruent angles potentially for angle? Well, in the big triangle, right, and the small triangle on the left here, triangle ACD, they overlap at angle A. So angle A is congruent to angle A by reflexive property. And there is your second angle pair. So the big triangle and the small triangle are similar by angle-angle similarity. And again, there's your angle A. So if you wanted to, we could create, it's over here. So triangle ABC is similar to triangle ACD, right? There we go. Okay, now let's take a look at the medium-sized triangle. I'll do it in green here. So now this would be triangle BCD. So how does it compare to the big triangle? Well, again, they both have a right angle at D, and then they both have angle B in them. So angle B is congruent to itself, reflexive property. There's your second pair of angles for the big triangle and the medium triangle, and they are similar by angle-angle similarity. And that is this statement right here. And then because they're both similar to the big triangle, they are going to be similar to each other. And again, you have to think about angles and how they work, right? But that is true. So we're going to do some problems up ahead that are going to involve pictures like this, creating similarity, or showing similarity, then creating proportions and solving those proportions. Okay, so here's the first question we're going to look at. It says, given right triangle ABC with altitude BD drawn to the hypotenuse AC. So that's the same setup as before. If BC is 14 and DC is 2, what is the length of AC? And again, note the figure is not drawn to scale. So X is this long side AC. When you see this long side being marked as something, know that you're going to use the big triangle ABC as one of your similar triangles, right? There are 3 triangles. We only need 2 at a time. The other triangle we're going to use is the medium-sized triangle because it has lengths marked, and that is BCD. So I need to write out the triangle similarity statement. So triangle ABC is similar to, well, these 2 triangles share angle C. So angle C will correspond to itself. In the big triangle, B is the right angle. In the small triangle, or the medium triangle, D is the right angle. So B and D correspond. That means that A in the big triangle has to correspond to B in the medium triangle. So you see how I broke that down? The congruent angle C, the right angle D and B, and then the third angle, or third vertex. So if I want to find X, X is on a C in the big triangle. What side in the medium triangle corresponds to AC? Well, that would be BC. And now, what other side in the big triangle am I given? Because the big triangle has to go on top. Well, in the big triangle, I'm given BC. BC corresponds to DC in the medium triangle. So there is my proportion. And again, these top sides come from the big triangle, and the bottom sides come from the medium triangle in a corresponding order based off of the similarity statement. So what is AC? So AC is X, BC is 14, BC is 14, and DC is 2. So to solve this, we simply cross multiply. I get 2x equals 14 times 14 is 196, divided by 2, divided by 2x is 98. And again, it's not drawn to scale, so don't be concerned about what the answer looks like. 98 is my answer. Submit that. Green check mark it up. Yes. All right, we'll do one more in this video. All right, so same setup here. So now they say if AD is 2 and DC is 8, what is the length of BD? So again, notice here, they don't give you this big, long AC, which means we're going to use the two smaller triangles. So the small triangle ABD with right angle at D, and the medium triangle BCD with right angle at D. So you have to kind of turn that small triangle to the clockwise so that it kind of lays like this. Am I doing it right? Yeah, like this. So D would stay put, B would come down here, and A would flop up. This is how they correspond, okay? So in these two triangles, so let's go triangle, let's name the small one ABD. Triangle ABD will be similar to triangle, so ABD, BCD. Okay, so again, just kind of rotate that small triangle to the right. So I want to find BD. BD in the medium triangle corresponds with CD in the BD in the small triangle corresponds with BC, CD in the medium triangle. I'm going to start over because I'm confusing myself. So there's my similarity statement. So I want to find X. So X is BD. That's the small triangle first. So BD in the small triangle corresponds to CD in the medium triangle. And then what other side do I know in the small triangle? I know AD. And AD in the small triangle corresponds to BD in the medium triangle. So we have X over CD, and CD is 8, equals, and then AD is 2 over BD, which is X again. So now when we cross multiply, X times X is going to become X squared, and 8 times 2 is 16. To solve this, we need to take the square root of both sides. Now, technically, when you take the square root, you should put a plus or minus with this 16, but we're not going to because X cannot be negative, it can only be positive. And we just simply take the square root of 16, which is a nice even 4. And there's your value of X. Okay, so the next video is going to have a couple more trickier examples of this.